Hi guys, I thought I'd give you a demonstration of how to complete the paired t-test exercise. If you're on this assignment description in my repository, you want to click on fork and copy this assignment repository to your own GitHub account. And once that is done, then you can download the, go to your own account and download the file, the zip file with the files for this assignment. Click on download zip, and when that's done downloading, you can open up the zip file and extract the contents. Make sure the show extracted files when complete option is checked in Windows. And we'll close the zip file and open the instructions which are on the answer sheet. Okay. Again, there's three main sections to this answer sheet. One section talks about study information, one section talks about data set information, and one section talks about test information. The study information are things that I think are important to look at when you're doing an analysis for real. There's not much for us to look at here for these learning exercises, but I do think it's important for you to keep in mind that any real analysis would be done in the context of collecting real data, and you should be familiar with how the data were collected and handled before the analysis was performed, because those things are very important to understanding and interpreting and applying the results from any analysis. There is some description in field chapter 10.3 and 10.91 about the research and the variables used in this example. So I would encourage you to go read those to understand the study design and the variables used there. Down in the data set information, we're going to look at the variables used in the data set and the level of measurement for each one. And so we're going to open up the invisibility rm.save data set in Jamovi. So I'm going to go open up Jamovi. And we'll go to the File menu, Open, Browse. I know this is in my Downloads folder, and in my paired t-test folder, and there's my invisibility rm.save file. I'm going to open that. And you'll see there's these are participants measured at 2 time points, one without a cloak and one with a cloak. Okay, and we can look at descriptives. We can make sure that these are set up correctly. We know that these were accounts of mischievous acts, so we're going to call that continuous. For no cloak, that is appropriate. Also continuous for cloak. That's good. We can see we have no missing data, but it's always good to look at descriptive statistics. So we'll go to exploration, descriptives, and put both of our variables in the variables box. These are continuous, so we don't care about frequencies, so we'll not check that option. We'll keep our mean and standard deviation, but we'll also get skewness and kurtosis and Shapiro-Wilk. And for plots, these are continuous, so we're going to get a histogram and a box plot to look at these. we can see we have no missing data, and things do not look skewed or kurtotic at either time point. And there's our histogram and our box plot. We don't see any outliers there, so that looks good. Some things to consider when looking at data accuracy. We don't have any additional manipulation we're doing here. No missing data issues, no outlier issues. And then if you were doing this for real, you might look at what descriptive statistics you want to report, and we don't need to fill in that part. So we are going to try StatCat here. If you haven't already done it, you want to install these modules for Jamovi. Again, that can be done by going in Jamovi and clicking on the modules button over here on the right, Jamovi library, and scrolling down to find the ones that you're looking for. And I already have JSQ installed, and I already have Walrus installed, and I think that should do us on this. And we're going to try this out. We're going to go to Jamovi, Analysis, StatCat, and Repeated Measurements. So Jamovi, Analysis, StatCat, Repeated Measurements. And we're going to put our two variables the related variables, so we're good. And we can see we have our two time points and variables and scores, and it gives us our paired t-test as an option. And if we have a problem with our normality assumption, we can use a Wilcoxon sign ranks test. So that is a handy tool for picking the right test. And we're going to conduct a paired t-test, and we're going to look at our assumptions. So our outcome variable is continuous. They are at both time points. We meet our assumption of additivity and linearity. We don't see, well, we could look and see what our relationship is between our time points with the scatter plot. And we don't see any problems with the curvilinear relationship here. So we're pretty good with that. Our normally distributed sampling distribution. For a paired t-test, we're actually interested in the normally distributed sampling distribution for the different scores, meaning one time point subtract the other one, not the scores themselves. So we're actually going to create a new calculated variable for the different scores. So if you were doing previous assignments, we would go create a new variable. We can go to data, and we can just leave this on the last option and go compute. And we're going to call this, I'm just going to call it difference. And I'm going to say cloak minus no cloak. And you want to make sure you are careful with your capitalization and spacing. Notice that no cloak has an underscore there, no space. And hopefully if I got this typed right, then we'll get different scores there in our variables. So we have that. So now we need to look at our descriptive statistics for our different scores. So we'll go to Analysis, Exploration, Descriptives, and this time we're going to look at our difference score and go ahead and get skewness, kurtosis, and Shapiro-Wilk, and a histogram and box plot. So here we have 12 different scores, no missing data. mean of 1.25. Standard deviation, fairly spread out for what that mean is. Skewness divided by standard error of the skewness is not greater than 2. Same thing with kurtosis. And our Shapiro-Wilks normality test is not significant. So our sample does not differ significantly from a normal distribution. So we meet our normality assumption. Again, this is a pretty small sample size, so we would be concerned about the normal distribution on these data. So that looks pretty good. Independent observations, obviously the paired observations are related to each other, but the different participants should not have any obvious relationships to each other, so we still have that independence of observations assumption. We've got paired observations. We don't have any extreme outliers. So once we've looked at all of our assumptions, we're ready to do our test. So our null and alternative hypothesis, the null is always some version of there is no difference. And in this case, it's going to be there is no difference between the no cloak and the cloak time periods. And our alternative hypothesis would be there is a difference in the mischief scores between the no cloak and the cloak observations. Our criteria for rejection, we're going to stick with alpha 0.05 for this example, but I do describe some times when you might change that and use something a little bit different. Now we're going to go to Jamovi analysis, t-test, and paired t-test. So analysis, t-tests, paired samples t-test, and we want to put cloak and or no cloak and cloak in our paired variables box. You'll see they go there on the same line. We're going to get students t-test and go ahead and get a mean difference and effect size. If we were worried about normality, we would go ahead and get a Wilcoxon-Sign ranks test. Let's go ahead and get descriptives and descriptive plots and a confidence interval on the mean difference. And let's go ahead and get our assumption checks. That's always nice to see. Okay, that looks pretty good. So we can see our t statistic is negative 3.8, degree of freedom 11, degrees of freedom 11, p-value 0.003. We do have a mean difference there of negative 1.25 and a confidence interval for the difference of negative 1.97 to negative 0.527. You'll notice that the value of 0 is not within the confidence interval. That's a good indicator that we have a statistically significant result, meaning that we are saying there's a true difference here between people's mischief when they're not cloaked and when they're cloaked. And we do have a Cohen's d, a very large one, of negative 1.10. Remember, these Cohen d's we can often look at like correlations. 0 to 0.3 would be small, 0.4 to 0.6 would be medium, 0.7 and above would be large, and this is definitely a large effect size. Our normality test, we looked at with the descriptive statistics, but again, it's not significant here. And we do have descriptives conveniently added to our output, and we do have a plot right there and a residual plot, which looks good. So you can look through the output to get your mean of the cloak and the no cloak observations, our difference between the means and 95% confidence interval for the difference, our value for t and our degrees of freedom, and p and our Cohen's d. Go ahead and try a robust t-test. So walrus robust paired samples t-test. So we'll go into Jamovi, walrus, robust paired samples t-test. And again, we'll move cloak and no cloak over and go ahead and check all the options, and we can see the difference is still significant. P equals 0.031 with the 95% confidence interval, and the Cohen's d does look a bit lower here in the robust t-test. So good to note that there's a little difference between those two. But we really didn't have many assumption problems, so I'd probably just stick with the regular paired t-test if I was choosing here. We can go ahead and try a Bayesian t-test. So we're going to do analysis, Bayesian paired samples t-test. So Jamovi analysis and t-test and Bayesian paired sample t-test. And we will move our cloak and our no cloak and cloak variables over. I guess they don't have to go on the same line. Oh, I guess they do. I don't know why that didn't work the first time. But when you got a problem, just clear it out and start over. And we'll go ahead and get all of our options here: posterior, prior and posterior, Bayes factor robustness check, descriptives plot, and go ahead and get these descriptives. And you can look through the output here. We're not going to spend a lot of time interpreting it, but you can see we looked at this before, and you'll see we have a Bayes factor that is pretty large this time, 16. So this is indicating that there's a significant difference between our no cloak and cloak observations. And we can see our means and standard deviations are reported there. Mischief is significantly higher under the cloaked condition compared to the no cloak condition, and you'll see this comparison circle is mostly showing all full, and so that gives you a good indicator that there's a significant difference between these two conditions. Interesting, if you have an interest, read more up on Bayesian statistics. We're not going to do a lot with it this semester, but it is interesting to try it out and take a look at these things. These will take a little bit of reading to understand better. Okay. And there's a little bit of description there about the prior specification and posterior is described in field compared to what we have here in Jamovi. You can read through that if you want. Again, we're not going to do too much with it. Alternatives when there are problems with assumptions. If we have a problem with, if we don't have any problems, we'll run the regular paired t-test. If we have problems with normality or outliers, then we can run the non-parametric Wilcoxon-Sign ranks test, or we could run a robust paired t-test under Walrus. Field gives a bit of a description of how to interpret results, and I gave you the field section there, chapter 10.10.1. And save your Jamovi OMV file. We'll go into Jamovi, File menu, Save As, browse to make sure you're in the right folder. We're in our paired t-test folder, and we'll just leave that name how it is and hit save. And export your results as or your output as a PDF. Right click somewhere in the output, go to all, export. Again, I go to browse just to make sure you're in the right folder. We are, and we can call this paired output or whatever you want, and save that. And there is no R markdown file we're going to run for a paired t-test because looking at linear models, it takes a more complex model than we're going to look at in this course. So that's going to be all you have. You want to put your files in your GitHub repository. Go to upload files, and you can drag your files over there. There's our PDF, and there's our OMV file, and you will click the commit changes button to save those, and then turn the URL for your repository into Canvas. And I'm just going to hit cancel on that. I hope that helps you understand how to complete the computer part of this assignment, and I hope you have a good day. We'll talk to you later.